Now that we've talked about some general things about packet construction in general, let's look particularly at a TCP segment. Let's take a TCP segment apart so you can see what it looks like. Now, TCP segments are a little bit different from UDP, IP, and other kinds of data packets because they have different functions built into them, and so they require a different packet construction. They do have some things in common with these other kinds of data units, however. TCP segments have built-in mechanisms that handle all kinds of things such as flow control, sequencing of packets and segments, establishing the communications through this three-way handshake, so they have flag fields, and it also has error correction. And because of that, a lot of the fields that you will see in a TCP segment are a lot different than some of the other segment or other datagrams that we'll look at. Now, we have the bit offset 0, 32, 64, 96, 128, and so forth. This is just to kind of tell you where things start. The diagram is a conceptual thing that sometimes is a little bit hard to follow. Sometimes it can be a little bit difficult to understand, but let's try to map it out for you. Keep in mind that an actual IP or TCP segment does not look like this, but this is kind of how it maps out. At bit offset 0, you've got a 32-bit field, which is the source address, and that is the IP address for the source for the sending computer. Then at bit offset 32, another 32-bit field, which is the destination address. That's where this data is going to. Now, while I'm not going to cover each and every single field, I will tell you about the important ones you need to look for when you're doing packet analysis. And as you get experience in this, you may actually find that you look at some of the other fields that are a little bit more obscure or not used very much. Protocol field, you'll definitely want to know. That's TCP, of course. Source port and destination port are extremely important for TCP packet analysis because you want to know which port the sender sent it on and which port it's destined for on the receiving machine. Then at bit offset 128, you have the sequence number. And remember, the sequence number is a number generated by the sending computer to start the communications process to sync these segments up as they go back and forth. At bit offset 160, you have acknowledgement numbers, and those are sent from the receiving computer. And they function pretty much the same as sequence numbers, except they tell the sending computer which number it expects next. It usually is the sequence number of the sending computer with one added, +1. And this number is incremented periodically as the receiving computer receives segments and needs to update the sending computer on which segments it needs to get next. Another important field is the flags field, and that basically is a 1-bit field, and that bit is either turned on or off, and that tells the communication process at what stage it's in, such as a sync bit or send bit starts synchronizing the session. The fin bit, if the fin flag, if it's turned on, indicates a finish of communications. And there are the other flags as well that we've talked about. That's a 1-bit field. Then we have the window. And the window, basically, that field tells you the window size that the receiving computer can receive, how much data it can receive at a time. The checksum, which we've mentioned also before, is a number generated that ensures the integrity of the packet, to ensure that it hasn't been damaged or altered. And what happens is when the checksum is computed in the sending segment, when it gets over to the receiving computer calculates the checksum again, and it should match. If it doesn't match, that means that something has happened to that segment along the way. Either it's been damaged in transit or it's been altered. Now, there are other fields as well in the TCP segment. The other important one that we can talk about today is the data field, and that's where data from the layers above it come from, and this is all the data that comes from the application, presentation, and session layers, and it's all encapsulated behind the TCP header.